Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, imagine this. A student loses a whole mark on a perimeter question because they used 12.3 as the exact length instead of recognizing it was rounded. One careless step, one lost mark. In this episode, I'm going to show you the small change that turns those lost marks into marks gained.
First up, the concept. What does upper and lower bounds actually mean in plain English? Think of a rounded number as a promise with wiggle room, a range the true value could be in. If your question says 12.3 to 1 dp, it means the true value could be a bit smaller or a bit bigger than 12.3. We write that as an inequality. That is what examiners expect.
So it's not exactly 12.3, it's a range. That feels obvious now, but I always just treated 12.3 as the number.
Exactly. Let's make the rule you can always use. For two n decimal places, take half of 1 in the last decimal place. Example, 12.3 to 1 decimal place means half of 0.1 is 0.05. So the lower bound is 12.3 minus 0.05 equals 12.25. And the upper bound is 12.3 plus 0.05 equals 12.35. We usually write that as 12.25 less than or equal to x less than 12.35. Lower bound inclusive, upper bound exclusive. Say that out loud in the exam. 12.25 less than or equal to x less than 12.35. Length inclusive.
For to n significant figures, find the place value of the last significant digit and take half a unit there. For example, 730 to 2 SF, the last significant figure is the tens place, so half a 10 is 5. The bounds are 725 less than or equal to x less than or equal to 735. Same idea, different place value. So, rounding to 2SF can change the scale. 730 is hundreds, but the uncertainty is tens. That explains some of my mistakes.
Good observation. Now a quick visual. Picture a number line with 12.25 here and 12.35 there, and 12.3 sitting in the middle. That little half step either side is the uncertainty. When you add or multiply numbers with bounds, that uncertainty moves through your calculation, and if you don't show the inequalities, examiners can't award the method marks.
Before we move on, an important caveat. Bounds apply to measurements and values given as to xdp or to xsf. They do not automatically apply to exact algebraic symbols, unless the question gives a measurement. Keep that in mind when you see letters in expressions.
Right, the exam technique. How do marks fall away and how do you secure them? Exam boards usually break a bounds question into 3 parts. M1 for setting up inequalities for each measurement, M1 for applying arithmetic correctly with those inequalities, and A1 for the final stated interval. So even if your final number is slightly off, showing the inequalities and method can still earn you marks.
Can you give an exact example of the notation the examiner wants? I worry about the small symbols.
Yes, write each line clearly. For example, 12.25 less than or equal to L less than 12.35 on its own line. Then 4.45 less than or equal to W less than 4.55 on the next. Then show how those go into the perimeter formula. P is equal to 2 times L plus W, so 2 times 12.25 plus 4.45 less than or equal to P less than 2 times 12.35 plus 4.55.
calculate the two ends and finish with 33.4 less than or equal to p less than 33.8 centimeters. That sequence wins method marks. The examiner is looking for the inequalities, substitution, and a final interval with units.
Common slips to avoid. 1. Forgetting to apply the factor, like multiplying by 2 for a perimeter, but only adjusting one side. 2. Mixing up decimal places and significant figures. 3. Dropping the inequality signs and just writing the number. Those are the small errors that cost marks.
Now, your quick win, a 60-second checklist you can use in every exam. Keep this in your head and apply it every time a measurement appears. Checklist. 1. Translate the words to an inequality. Write it down. 2. Keep consistent units. 3. Substitute the inequalities into the formula. Show the left and right separately. 4. Calculate the exact lower and upper results and state the final interval with units. 5. If in doubt, write the inequalities. They are easy method marks. Read them out as you write. Lower bound equals. It helps the examiner see your thinking.
That checklist is great, but what about a quick check to catch mistakes before time runs out?
10-second backwards check. Pick a value inside your final interval, the midpoint is ideal, and substitute it back into the original condition to see if it makes sense. If your midpoint for the perimeter is between the two computed bounds for sides, your maths likely holds. This catches arithmetic slips and wrong inequality signs fast. Don't skip the check. The examiner wants to see your method, and this shows you know what the interval means.
Worked example now. Put this on paper with me. Question. A rectangle has length 12.3 centimeters, correct to 1 decimal place, and width 4.5 centimeters, correct to 1 decimal place. Find the upper and lower bounds of the perimeter.
Step 1. Convert each measurement. Length 12.25 less than or equal to L less than 12.35. Width 4.45 less than or equal to W less than 4.55. Write those on separate lines so the examiner sees them. Step 2. P equals 2 times L plus W. Replace L and W with the inequalities. 2 times 12.25 plus 4.45 less than or equal to P less than or equal to 12.35 plus 4.55. Evaluate the left. 12.25 plus 4.45 equals 16.70. Times 2 gives 33.4. Evaluate the right. 12.35 plus 4.55 equals 16.90. Times 2 gives 33.8. So 33.4 less than or equal to P less than 33.8 centimeters. Finish with the unit and you're done. That's M1 for inequalities, M1 for substitution or method, and A1 for the final interval.
Nice! Showing the inequalities on separate lines made that feel much clearer. And the midpoint check would give 33.6, which is inside the interval, so I know it's sensible.
Exactly. Let that sink in. Small, neat steps win marks. A quick note on notation. Use less than or equal to for the lower bound and less than for the upper bound when the number is rounded to something. If the question says greater than or gives inclusive wording, match the wording. The examiner is precise. So should you be.
Before we close, 2 final tips. Tip 1, always keep units visible at the end of your interval. Centimeters or meters matters. Tip 2, if you see algebra and measurements together, only apply bounds to the measured numbers unless the question explicitly tells you otherwise.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable bounds checklist at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.